500 error on checkout for every user. Database URL was undefined in production, but all 285 CI tests passed. Next.js 16 uses at Next.js for Vitest compatibility, but ensure you install at Vitest/plugin React and set environment. JS DOM for component tests. The Roman 6 Stub Global API is available in Vitest v034+. Older versions may require global thisFetch equals VIFN instead. Server components cannot be unit tested in Vitest because they require a server runtime. Instead, use Playwright to test their rendered output by asserting on the HTML content. This snippet shows how to verify a server component renders correctly in an E2E test. The article mentions runtime Env validation with Zod, but a critical production caveat is that process Env in Next.js is only available at runtime for server-side code. For client-side Next public variables, they are inlined at build time. Ensure your Env validation runs on the server and that client-side code does not rely on server-only Env vars. Let's break down testing Next.js applications, unit, integration, and E2E testing, how it works, and the exact mistake behind that failure. Testing a Next.js 16 app requires more than a single tool. Vitest handles isolated logic, utilities, hooks, schemas. Playwright runs against a real server and browser, catching caching and rendering bugs. Environment verification tests ensure production config matches expectations. Together, they cover logic, behavior, and configuration. Setting up Vitest for Next.js 16 requires a configuration file that resolves at imports and sets up the JS DOM environment. You also need a setup file to mock global APIs like fetch and intersection observer that aren't available in Node.js. This Vitest configuration sets up JS DOM, enables globals, and defines path aliases matching your Next.js tsconfig. The setup file will mock fetch and intersection observer so component tests don't crash. Playwright E2E tests run against a real Next.js server. The configuration defines the test directory, browser projects, and a web server block that starts Next.js, either the dev server or the production build. In CI, always use the production build to catch caching and rendering differences. This Playwright config sets up Chromium, retries on CI, and uses a web server to start Next.js. In CI, it runs Next Start production build. Locally, it uses Next Dev. The base URL defaults to localhost 3000. This Playwright test walks through a complete checkout flow. Load a product, click Buy, fill in payment details, and submit. It validates real data fetching, navigation, and server action execution. This is the kind of test that catches production bugs Vitest can't. Server actions need both unit and E2E tests. Unit tests with Vitest validate the business logic, correct handling of valid data, invalid input, and system errors. Mock the database and cache revalidation functions. Then use Playwright to test the full form submission flow in a real browser. These unit tests cover 3 paths: success, validation error, and system error. The database and cache are mocked. Notice the error test ensures the system error message is not exposed to the user, a common security miss. Each test uses fresh mocks via beforeach. Caching is completely different in test versus production. Vitest has no cache. The dev server has no cache. Only the production build has full root cache, ISR, and data cache. Use Playwright tests that run against Next build and a Next start to validate cache headers, revalidation, and staleness behavior. These cache tests verify ISR revalidation and cache headers. The first test triggers revalidation via an API endpoint and checks that the content changes. The second test asserts the cache control header contains the expected directives. These tests must run against the production build. Test isolation prevents flaky failures. In Vitest, use Roman 6, clear all mocks, in beforeach. In Playwright, clear cookies and local storage between tests. For database-dependent tests, use isolated data fixtures or transactions. Shared state is the #1 cause of intermittent test failures. This code shows isolation patterns for both Vitest and Playwright. In Vitest, clear mocks before each test. In Playwright, clear cookies and storage in a before each hook. This ensures tests don't interfere with each other. Environment verification is the third testing layer. It validates that the production environment has all required variables, that public variables don't contain secrets, and that the server can start successfully. This catches the works in staging, fails in production gap. This environment verification test checks that all required env vars are present and that no next public variable accidentally exposes a secret. The third test is a placeholder for a server startup check, often implemented as a CI script that starts the server and hits a health endpoint. This is the same issue we highlighted at the start. Here's exactly why that happened. The team deployed to production, but the production environment was missing database URL. The server started fine because the variable was only accessed lazily when a user hit the checkout page. All CI tests passed because they ran against a staging environment that had the variable. No runtime validation existed to catch the gap. The production incident occurred because database URL was undefined at runtime. The fix adds Zod runtime validation in lib/env TS that crashes the server on startup if any required environment variable is missing, preventing silent failures. The fix involved adding a lib/env TS file with Zod schema validation that runs at startup and crashes the server with a clear error if any required variable is missing. Playwright tests were updated to use a production-like environment file. A pre-deploy CI step now compares environment variables between staging and production. Without runtime validation, the server starts even if a critical env var is missing. The error only surfaces when a user triggers code that accesses the variable. Adding a Zod schema that calls process exit 1 on startup catches the issue immediately, preventing the tests pass, production fails scenario. The dev server has no full root cache, no ISR, no data cache. If your E2E tests run against Next.js, they won't catch caching bugs. Always run cache-related tests against the production build using next build and a next start. Mocking fetch to always return success means your tests never exercise error handling, loading states, or network failures. The real API might return a 500, timeout, or unexpected shape. Always supplement with Playwright E2E tests that hit a real server. To debug test gaps, first check if environment variables are validated at startup. Then audit your test suite for excessive mocking. If you mock fetch everywhere, you're not testing real behavior. Finally, replace fixed wait times with element visibility assertions to avoid flaky tests. Let's run through some common interview questions. Design a testing strategy for Next.js 16 e-commerce app, 3-layer, Vitest for logic, Playwright for E2E, Env Verification for config. Why can't Vitest with mocked fetch replace Playwright? Vitest has no real server, no cache, no real browser. It can't catch caching, rendering, or env bugs. How to test ISR behavior? Playwright against production build. Prime cache, trigger revalidation, verify content changes. And a few frequently asked questions. Why do my Vitest tests pass but the app fails in production? Vitest mocks fetch and has no real server. It misses caching, env vars, and real API behavior. Should I run Playwright against dev or production build? Production build, next build, and a next start. Dev server has no caching and different behavior. How to test server actions? Unit test business logic in Vitest with mocked DB, then E2E test form submission in Playwright. Let's recap the key takeaways. Vitest tests isolated logic with mocked data. Playwright E2E tests catch real caching and rendering. Server actions need both unit and E2E tests. Cache behavior is under-tested, dedicate E2E tests. Ready to go deeper? Up next, internationalization I18N in Next.js 16, then self-hosting Next.js, Docker, Node.js, and deployment strategies, then OpenTelemetry, monitoring, and observability in Next.js 16 and production checklist, security, performance, and CI/CD for Next.js. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.